Hello, my bomb blowers and module masters, and today I am here with another Keep Talking and Nobody Explodes modded module tutorial, and today I am here with the module, the Legendre symbol. The Legendre symbol has had a stigma of being a module that most people just press a random button on and it just usually has a 50% chance of solving. Just press a button, it's probably right. But today I will teach you a strategy on how to solve this module. What you're supposed to do is, the module, as you can see by the image, has a fraction. What you're supposed to do is figure out if the top number is a quadratic residue modulo m. However, I have no idea what that means. The strategy that I will be using in this tutorial was given to me by KTaNE, so thank them for the strategy. Let's go ahead and get started. This module does not require any edge work, but because I forgot to turn it off in the mission generator, we're going to have it
All
off in the
available
tutorial.
experts,
Sorry.
please report to room A9.
So this is the Legendre symbol. You've got two numbers. And two things will be true about these numbers. The top number will always be a smaller number than the bottom number, and the bottom number will always be an odd prime. So as you can see in my notepad, I have outlined a stack. This stack will be filled with a certain number of negatives. Once we finish the process of solving the module, we're going to be taking the number of negatives on this stack. If the number of negatives on the stack is even, we're going to press the R button. If it is not even, or odd, we're going to press the N button. If you are incorrect, the module will strike and it will generate a completely new sequence. So let's go ahead and get started with the strategies that I will be using for this tutorial. There are 4 distinct strategies to this module. So the goal of the module is to take what's on the module, split it into smaller fractions, and eventually eliminate those fractions. So we're going to start with 168 over 181, and we're eventually going to whittle this down to nothing. There are 4 different strategies that we are going to use to do this. So the first strategy is relatively simple to remember. If at any point you have a fraction whose numerator is a square number, you just go ahead and get rid of that fraction altogether. As simple as that. But, as you can see, 168 is our numerator, and that is not a square number, so we're going to have to rely on other methods to whittle this fraction down. So the next property we're going to talk about is total multiplicativity. If we have a fraction where the numerator is not prime,
Emergency
which,
cleared.
I mean,
All personnel, please return to your stations.
the last digit is even, so we can already tell 168 is not prime. So we can split this into 2 smaller fractions. First of all, we're going to figure out what our factors of 168 are. For the purpose of this tutorial and showing off the different properties, I'm going to divide this by 2. So the way we split up this fraction into 2 smaller fractions is we're going to take a pair of factors that multiply to be the numerator, so we're going to take 2 and 84. We're going to have both factors over the old denominator, so 2 over 181 and 84 over 181. Then we get rid of the old fraction, and now we have 2 fractions. Let's go ahead and whittle down this 84 a bit. This is a multiple of 4, which gives us 21, so let's go ahead and split this into 4 over 181 and 21 over 181. Now we have 3 fractions. However, in this middle one, the numerator is 4, and 4 is a square number, so we can just go ahead and get rid of the fraction. Next, let's look at this 21 over 181. There is a specific reason I'm saving this for later. 21 is still not prime, so we can split it into 3 over 181 and 7 over 181. So now we have 3 fractions where the numerator is prime and the denominator is prime. So, in the case that you have a fraction where both numbers are odd primes, we're going to use quadratic reciprocity. So for this rule, we're going to convert this fraction into a different fraction and we may be adding a negative to the stack. So first, we're going to take both of our numbers that are a part of the fraction and take them both modulo 4. So for this top one, 3 modulo 4 is 3, and 181 modulo 4 is 1. If either of the two numbers on your fraction, modulo 4, is equal to 1, you do not add a negative to your stack. If both of the numbers, modulo 4, are 3, then you add a negative to the stack. You're dealing with two prime numbers, so a prime modulo 4, an odd prime modulo 4, can never be 2 or 4. Since the denominator, modulo 4, is 1, we are not adding a negative to the stack. Then we're going to transform this fraction into a different one. It will be transformed into the numerator is the old denominator modulo the old numerator, which gives us 1. And then the new denominator is just the old numerator. So that is how you use quadratic reciprocity. And then we can look at this. The numerator is a square number, so we can go ahead and get rid of it. Now let's take a look at 7 over 181. We know that 181 modulo 4 is 1, so we're not going to add anything to the stack. This is another case where we use quadratic reciprocity, because both of the numbers are odd primes. We know that this mod 4 is 1, so we're not adding a negative, and then we're just going to transform this into a new fraction. 181 modulo 7 is 6 over 7. Since our numerator is not prime, we're going to split this into two different fractions, 2 over 7 and 3 over 7. And now we are left with these. I will now talk about the final property that we're going to use. And we're going to use this property when we have a fraction in the form of 2 over an odd prime. Whenever you have this, you're going to take the odd prime modulo 8. If it is 3 or 5, we're going to add a negative to the stack. If it is 1 or 7, we're not going to add a negative to the stack. So it is 5, so we're adding a negative to the stack. And then once you do this, you can completely get rid of that fraction. You're done with it. We can do the same thing for 2 over 7. 7 modulo 8 is 7. 7 means we're not adding a negative to the stack, so we can get rid of this fraction. What we're basically doing in this module is we're multiplying a certain number of 1s and negative 1s with each other. So 2 negatives multiplied by each other make a positive, so 2 negatives will cancel out. However, a positive times a negative is still a negative, and a positive times a positive is still a positive. So we could add a positive to the stack, but it effectively does nothing. It doesn't change the sign of our answer. Finally, let's take 3 over 7. They're both odd primes, so 3 modulo 4 is 3, and 7 modulo 4 is 3. So we're going to add a negative to the stack, because both of our numbers modulo 4 are 3. And then we're going to get a new fraction. Old denominator, no, don't cube it. Old denominator modulo old numerator gives us 1, and then the new denominator is the old numerator. And now the numerator is a square number, so we can get rid of the fraction. We have eliminated the fraction, we split it up into nothing. So now we're going to take a look at the stack. There are 2 negatives. The negatives cancel out and make a positive. So we have an even number of negatives, meaning we're going to press the R button, and the module solves. Let's take a look at another example. I would like it if we had a square number on top, but we don't. So if you actually get the case where you have a square number on the top, you can just go ahead and hit the R button, because the square number on the top means the entire fraction just cancels, meaning you have an even number of R's since you didn't add any negatives to the stack, and just press the R button. Let's take a look at, let's try this one. Is 113 prime? It is prime, okay. So now we're starting with a prime over a prime. We have two odd primes, since the bottom one is always a prime. I don't even need to check it. Let's do quadratic reciprocity on it. Let's take both numbers modulo 4. Alright, this is already 1, so we know we're not going to add a negative to the stack, even if this modulo 4 is a 3. And then let's make our new fraction. It's a 6 over 113. We can split this into two separate fractions, 2 over 113 and 3 over 113. Let's deal with the 2 over odd prime first. 113 is prime, yep. So take the numerator, modulo 8. It is a 1. 1 means we're adding a positive, so it has no effect, and we're going to get rid of the fraction. Then we're going to do quadratic reciprocity again. 3 modulo 4 is 3, but 113 modulo 4 is still 1, so we're not adding a negative to the stack. Then we're going to take 113 modulo 3, which is a 2, and then over 3. Then finally, we're going to use a 2 over odd prime condition. The numerator modulo 8 is 3, so we're adding a negative to the stack, and then we can get rid of our fraction. So now we have an odd number of negatives in our stack. In this case, we press the AND button. And that is a solved module. That's basically how this module works. Just use those 4 rules, just canceling out the top if it's a negative, splitting it up into 2 different fractions if the top is not prime, flipping and modulating if you have 2 odd primes, and then getting rid of the fraction if it's 2 over an odd prime. Now you can use this property, but I don't recommend it. Because say we're taking, let's see, is there an odd prime here? That looks like an odd prime. Even if it's not, I'm still going to use it. So you can take 491 minus 389. And then you can take it minus 389 again, and you'll get a negative number. So this is just saying if you ever somehow get a fraction in the form of negative 1 over p, you can modulo 4 to add a negative or a positive to the stack, and then get rid of the fraction that way. But I don't know why you would ever use that, honestly. Speaking of this, let's go ahead and do this last example. After this, I will stop the tutorial. We have 389, which is prime, so we're going to start with quadratic reciprocity. Let's see, this modulo 4 is a 1, so we're not adding a negative, and now we're going to make our new fraction. It's 102 over 389. Our top number is not prime, so let's see if we can split it. What is it divided by 3? 34 divided by 2 is 51. Okay. Are there any other factors? Let's just try a few. 6 and 17, I don't really care about that. Okay, no. Let's use 2 and 51. 2 over 389 and 51 over 389. So we can use the 2 over odd prime rule because 389 is prime. So 389 modulo 8 is 5, which we can check is a negative. So we're going to add a negative to the stack and then get rid of it. Oh, that negative was from the last example. I forgot to remove it. Yeah. Anyway. And then 51 is also not prime. It splits into 3 and 17, so we can split that up. Both of these are in the form of odd prime over odd prime, so we're going to take 389 modulo 4, which is 1, meaning neither of these are going to add a negative to the stack because they both have a number modulo 4 equals 1. So we're going to take 389 mod 3, which is 2 over 3. And 3 mod 8 is still 3, so we're adding a negative. 389 mod 17 is 15 over 17. 15 is 3 and 5, so we can have 3 over 17 and 5 over 17. Both are odd primes over odd prime. So 17 mod 4 is 1, meaning neither of these add a negative to the stack. And then 17 mod 3 is a 2. So this becomes 2 over 3, which adds a negative to the stack. And then 17 mod 5 is a 2, which becomes 2 over 5. And then 5, mod 8 is still 5, which adds negatives to the stack and gets rid of this fraction. We have 4 negatives, so all the negatives cancel out, meaning this is an R.
That is absolutely right.
That is basically this is a pretty foolproof strategy on solving the module. And it does use the fundamental properties of the module, but I don't know how they apply to a specific math sense. If you told me to give a lecture on this, I could probably misinform your students. That'll be it for this tutorial. Thank you for watching, and have a nice day.